Okay, so I'm going to do my best to explain this. Okay, so for the first 1 through 20 questions, we're only going to have these 4 rules. Modus ponens, modus tollens, pure hypothetical syllogism, and disjunctive syllogism. The way you can sort of know how to use them, and we'll get into that in an example for all of them, is through those symbols. So this one right here has a horseshoe, and this one has a V. And we'll see how each one has a different outcome, such as making them either negative on both, making one of them negative only, or as this one kind of switches them up a little. So we're going to start with one, or our first problem, question number 2. I got too much light. Okay. Okay. So in the third line, we're giving our conclusion, which is anything after these 2 lines, that is the conclusion that we have. In this one, it is A. So at number 5, we're going to press A. Excuse the handwriting. I got to hold the camera with one hand. Okay. So the easiest way to sort of do this is try to find another A in here. In here, we can see that in question number 2, we have an A right here. So we have to prove how we got this A and get it from here. And so we have to go and look into our equations. Now, seeing that we have a V here, there's only one equation that we can use, and that is ds, because it has a V. All the other ones have horseshoes involved, so we'll have to use this one. That easily narrows it down. So from the outcome there, P VQ leads to negative B, or like little squiggly line P and Q. So D becomes like a negative. Since we don't have a negative here, we have to write it. So it becomes squiggly line, and then D. Okay. And then A is proven here. So the way you would write this, and it's very important the order that you do it, is 2 and then 4. Now the reason 2 goes first is because that's sort of like the origin. This is the origin of where you get both of the answers. For A, you get it from here, and from 4, which proves 5, is right here, D. So 2 goes first and then 4. This is to prove 4. Small tip, most of the time, you're going to, like, the one that precedes it tends to back it up. So since we're going to try to prove 5, most of the time, 4 is going to be here. It can move around a little bit later on, but for now, it's going to be that way. Okay, so now that we have D and we proved it, now we need to move on to the other one. So we need to prove negative D, and then, just prove negative D. So we have a horseshoe here. Now we have negative E and negative D. Now, the only thing that we haven't used, other than 2 and 4, which is, this is hard. We've used those. We have 1 and 3. Now we have this equation, full equation here. And the only way to get a negative E and D is we just have to look at our equations here. P and Q separates them both into positives, or just their native selves. Well, we have a negative D. This is not a negative D. We have an E. This is not a negative E, or a negative E, so it wouldn't work here. We look over here, modus tollens, P and Q turns into negative Q and negative P. Well, if we look over here, that would work great. Turn this into a negative, we get negative D, and then turn that into negative, we get negative E. Now in this case, it would be 3. that way. And we can see that for the most part, all of them are like sort of proven. 1 and 3 are here and here, and then 2 and 4 is right here and here. Yeah. For the most part, you don't need to like have number 5 written down, so it's okay if you only have 1, 2, 3, and 4. And then this question's already done, but later on, there can be cases where a question only has one proof, but that's for later on. For right now, most of them are just going to have all numbers leading up to 4. So 1, 2, 3, 4.